We're going to talk today about transpiling TypeScript, or compiling TypeScript, or as I just found out today existed, transcompiling TypeScript. Essentially just the process of converting TypeScript to JavaScript. Some of the alternatives that exist outside of TSC, some strengths and limitations of each, and some speed hacks along the way. So just to intro a little bit about ourselves first. Kilian, you want to go first?
Yeah, I'm a senior UI engineer here at ExtraHop. But before that, I've always been doing full stack development. So it's interesting to be focused on UI. And when I get time, I'm very interested in playing with different programming languages, technologies including Elm, Elixir, React, and TypeScript.
And like Kilian, I'm also a senior engineer here at ExtraHop, also working on the front end on the UI team. I also too would consider myself more of a full, or I guess whole stack developer. I started my career actually doing Verilog and FPGA design and worked kind of all the way up the stack until now I'm doing entirely front end development, particularly with languages and frameworks like React and TypeScript, which I've grown to enjoy quite a bit from working on. So yeah, let's jump into it. So you have an idea that you want to build an application, be it some microservice or maybe the next greatest front-end framework, or maybe a crypto trading bot, who knows, some sort of application, and you want to use TypeScript as a language for that app. Great, good first choice, depending on the app. So you've gone off and you started writing code, used all the advanced features of the language, types, advanced types, enums, generics, everything, even the latest and greatest features of ES 2018 and beyond. So now you have all this great source code, but how do you actually run it? How do you actually get it to do anything? As of right now, there really isn't any native way to just compile it to machine code and have it run. But there is a couple of kind of close alternatives. You guys have ever heard of this open source project called AssemblyScript, but essentially it just compiles TypeScript down to WebAssembly modules, which gets you kind of the way there, but it obviously has a very specific use case. It's also a pretty young project, so it's not 100% production ready, but still a unique one that I wanted to at least call out. And then the second bullet point that I have here, just out of curiosity, who here has heard of Deno before? Okay, got about half. Super excited about this project. It was actually created by the same guy that created Node.js, Ryan Dahl. Deno is actually just Node, but with the letters mixed around. I don't know why I decided on that, but yeah, it's a secure runtime for TypeScript that's built on V8 and Rust in Tokyo. But essentially, it allows you to, again, air quotes, natively run TypeScript. But in reality, behind the scenes, even though you're executing seemingly TypeScript directly, it's still running the TypeScript compiler behind the scenes. And then executing that, since it still has to run on V8, which is the JavaScript engine that obviously Node and Chrome use. So it's still a super interesting project that I've been following since its inception. But yeah, if anybody wants to do a future talk at this TypeScript meetup, I would love to hear more information about this one. So a cool idea for a talk. But anyways, but yeah, in most cases, if you want to run TypeScript, you first have to compile it down to an ECMAScript standard version of JavaScript. And more often than not, you're probably going to be using the compiler that is built into TypeScript, which is clearly available in the Microsoft GitHub repo under source compiler. You can read it if you want. There's also a command line version of it that comes shipped with TypeScript called TSC. So what is the TypeScript compiler actually doing? It's kind of doing two main things. One is type validation, and the other one is transpilation, or the actual act of converting TypeScript to JavaScript. So the example that I have above, you have a constant named foo of type string that you're assigning it to a numerical value of 5. Passing into TypeScript, that'll complain, obviously, because you can't assign a number to a string. So it'll complain with the following error. But the transpilation of the same exact code will work just fine. It's totally throwing away all the types, and you end up with var foo equals 5. I guess depending on the version of ECMAScript that you're compiling to, it might change the counts to a var to be more universally supported. But yeah, that'll work just fine. So just taking a slightly deeper dive into the compiler itself, kind of wanted to highlight kind of the 5 main functional kind of core blocks of the compiling pipeline. This will make sense in a couple of slides. But essentially, it's split kind of between the scanner, parser, binder, checker, and emitter. And just real quickly, how this data flows through it. You obviously have your TypeScript files at the top left, so those are read through the scanner, and a token stream is generated. Token stream is then read by the parser, and an AST or abstract syntax tree is built. That then gets fed through the binder, and symbols are created, and the symbols with the abstract syntax tree are fed in through the checker. And the checker is kind of like the largest, most complex part of the compilation pipeline. This file, I think the last time I checked, was over 32,000 lines long. They probably should split that up, but I don't know. GitHub won't even render it because it's too long. But this is where all the magic happens. So this is where all the type validation happens. That's one output from it. And then combined with the emitter itself, that's how you actually generate the JavaScript files that end up in your build or dist directory. In addition to that, you have source maps and type definitions that are also generated from that. So let's say you have a large TypeScript project that just takes forever to build, and you're having a really hard time figuring out why exactly it's taken so long. You run TSC and you sit there for 30, 40, 50 seconds, and it just doesn't make sense why it's taking so long. What part of that pipeline is actually taking so long? So there's actually this flag that you can pass into TSC -- diagnostics that illuminates kind of where the time is spent during the compilation process. So I actually ran that on a project of fairly good size. I think it's about 3,200 files and almost 500,000 lines of code. And the output that it gives after it does a compilation, you'll see on the left-hand side here. And what's cool about this is it'll actually show you just how much time it actually spent in each of these components that I just previously talked about. So it looks like for this one, it didn't actually spend that much time in kind of the first scanner, parser, and binder. But then if you look at how much time it actually spent in the checker, we're almost at 17 seconds, which kind of makes sense because, again, that's where all the heavy lifting is taking place. Then another 5 seconds per emitter for actually outputting all of the resulting JavaScript files. So, yeah.
Is that our UI?
That is. Spoiler alert. So that 26/27 seconds, that's still a little bit slow for me. I'd love if that was a lot faster. But I guess why does it even matter that it's as slow as it is? Well, any incremental speed improvements you can make for a TypeScript compile, especially if it's something that's used in a company, if you multiply that times the number of times you compile it throughout the day and the number of developers that you have, the end result could be actually a pretty dividend-paying performance improvement that actually makes the efficiency of the entire engineering org that much better. So any small improvement that we can make is desirable. So that's kind of the goal. That's kind of what we're going to be talking about for the rest of the talk is how do we make this process faster? What tools and tricks do we have up our sleeves to actually improve the performance of what you just saw? And what can we do about it? So one thing that actually just came out probably within the last couple of weeks with TypeScript 3.4 is a feature called incremental build. If you're using the command line utility for the TypeScript compiler TSC, it's enabled by this -- incremental flag. And essentially what that does is it builds up a project dependency graph on first run and saves that into a file called .tsbuildinfo, but that can be changed by other tsconfig options. But essentially, that gets saved, and then on successive builds, it'll reuse that to find the most efficient way possible to regenerate just the bare minimum number of files and do the bare minimum number of type checking in order to come up with the same output that you had previously. So it's pretty similar to the watch flag if you ever use that with TypeScript, but you're getting it with full builds, which is awesome. So you can run this, go home, come back the next day, and as long as you still have that file, the next full build will still be just as fast as the last, which is pretty cool. Does it actually work? So I actually took that same exact project that we had previously that was 27 seconds. All I did was I went in and I just touched or updated the date timestamp of one of the files, so I didn't actually make any changes, and reran the tool. Previously, a rerun would be the same exact 27 seconds, but as you can see on the right-hand side here, 5 seconds. Significantly faster, just because I did have that cached tsbuildinfo file in my output directory. You can kind of notice too that check time is 0, which kind of makes sense since I didn't actually change any types whatsoever or any actual source. It didn't need to run through that file at all. So that saved the most amount of time. And then obviously since I didn't change anything. I didn't have to write any new JavaScript files. So that's why my emit time is also 0. So a pretty drastic performance improvement, I'd say. But let's say you're using like Webpack. With Webpack, when you want to wrap and run TypeScript, you're probably using the loader TS loader. And unfortunately, TS loader actually doesn't use the command line version of TypeScript's compiler, TSC. It uses an API to interface and actually do the builds. And as of right now, TypeScript 3.4, there's no way to actually enable this incremental build feature if you're not using the command line utility. So kind of a downer, but I did see that it was actually scheduled to include that in the API by maybe 3.5, so this might be an option coming up. But even still, there's options to improve performance with caching if you're using Webpack. This is a loader that we actually use here at ExtraHop called Cache Loader, and essentially does exactly that. It caches the output kind of from an outside perspective of a series of loaders that you run before it. Performance of this isn't as good as what you saw previously with the incremental build. I've seen usually like a 2x improvement instead of like a 5x improvement when we saw previously an incremental build, but still an improvement nonetheless. And then outside of that, if you're kind of stepping outside the bounds of just improvements with caching alone, and you're actually building on a machine that has multiple cores, which probably many of us do, I wanted to call out this other plugin, Fork TS Checker Webpack plugin. Essentially what it does is kind of what the name implies, it forks the process that does type checking and runs that on a separate process from what it actually does the transpilation. Because there's nothing that says you have to do them the same, and we've seen, I didn't have hard benchmark numbers on this one, but we've seen performance improvements, again, around 2x roughly with using this one as well. But definitely another cool one to check out if you're looking to extend your Webpack config even more so. And with that, I'll throw it back to Kilian to talk about some other alternatives to vanilla TypeScript compiler. Yeah.
So yeah, alternatives. Since we can't use incremental and waiting to see how it works when in the context of Webpack, actually, there are other options that I will more or less review and show, I guess, the pitfalls and benefits of each of them. So the first of all, and I think most well known, is the TypeScript preset for Babel. So what it does is it just removes TypeScript annotations, which is great, and then will handle everything else to Babel for transformations into whatever version of JavaScript you need in your browser. So it has some limitations. I'll go through them because these limitations apply to the other tools as well. It doesn't support namespaces if you've used namespaces in TypeScript, which is okay because there are very few reasons to use them nowadays. There are alternatives. It doesn't support const enums because they require type information to compile, and this, again, doesn't do any type checking, doesn't know what types, it just tries to infer them from the code and remove them. But that's okay because I haven't needed to use const enums ever. So it doesn't support export equal, import equal. There are other syntaxes to do this, so you'll have to transform or upgrade if you're doing that. And it behaves like the isolated modules option that the TypeScript compiler has. That makes sense because basically it's saying, hey, I don't know anything about your other files and about the types in the other files. I can't make any deductions about that. And that's essentially what isolated modules is. It's just file on its own, information about other stuff. And it doesn't know anything about your TS config, but it does support a number of similar configuration options. Though generally, really you want to use them because it's supposed to be just removing types, right? So this can be great if you're passing files from TypeScript into Babel for some reason, because now you will have to go through them only once, right? You're on Babel and that's it. It doesn't have to go to TypeScript and then pass that down into Babel. And we haven't tried it. So this is the information we have. But even though we haven't tried it, we've tried other things, including that do more or less the same thing, including one I'll review later that is a fork. So, but for now, SWC, which took a while to find what it meant, it's speedy web compiler. So it's written in Rust, which for me is like yay, right? It's supposed to be fast, probably, or that's what I expect. So it's great because it includes parsers for ES 2019, JSX, and TypeScript, which is exactly what we need at least in the UI project here at ExtraHop. But it outputs any version of JavaScript. So if you are supporting older browsers, it works. So yeah, these are the claims, basically what I said. And it's 16 times faster than Babel, and here it means Babel as well as Babel TypeScript preset in the case of TypeScript. So our experience with the speedy web compiler is not so good. It's probably just because it's new, and it's also probably because our code is really big and has many cases of everything. They've tried it with many other projects that are big, and it works. So a lot of problems that I've seen when running this are related to arrow functions. I'm not sure why, but this is common in all the similar projects that I've tried. They all have problems with arrow functions and type syntax in there. I don't know why, but it's there. And there were so many problems that I just let it run for like 20 minutes, and eventually it crashed. So that's how far I got with this. And the reason being that there is another project that claims to be faster than this. So it's not Rust, but it's TypeScript, and that's Suckrace. Like I said earlier, it's a fork of the TypeScript preset for Babel. So the limitations that we mentioned apply, just like in the SWC. But the difference here, and the reason why it's faster, is that it assumes that you're using a modern browser or a modern Node.js version, which means it has to do a lot less to transform or to transpile to older versions. It essentially tries to literally remove type annotations. Doesn't then need to decide, oh, but what version are you using? Let me transform this new syntax into the old way of doing things. Because of that, and the other reasons, I guess, it's new, and why wouldn't you do it with the TypeScript compiler if it's a little slower in production time? I mean, you're not constantly building the production bundle, I guess, right? So it's not intended for production, but works great for development where you want that speed that Nick was mentioning every time that you change a file. So it transforms JSX, enums, VS modules to CommonJS in the same way that TypeScript does, and the same way that Babel does. So it should just result in the same behavior in the browser. Class fields, except the new private fields, numeric separator, and the optional catch binding, which means there's no error there to use. Interestingly, it also removes flow type annotation. So if you have multiple projects and one of them happens to be flow and you want to use the same transpiler everywhere, this is a good option. And it supports React hot loading if you have that set up in one way or another. It's similar in configuration options to other React hot reloading projects that exist. One nice thing that I found is that, well, it does generate maps, very simple source maps, though there is a problem with the Webpack loader for it, which means it doesn't in Webpack, but in Rollup and others it does. But one nice thing is that even without that, it gives you a pretty good developer experience. You can go into developer tools, and this is how it would transform your TypeScript code. And if you see, it respects the source lines. Comments, type information. It's smart enough to decide, like you can see the export right at the end. It doesn't do it in a new line. It does it right there. It works. The syntax is valid, and it means that I can go into my developer tools, see the source, and I'm looking at a code that's, except for the types, very similar to what I was writing. And if I go into the editor from that, I'll be looking at the exact same source. So you can integrate it with Webpack. Like I said, there's that problem with the map that hopefully will be fixed soon, as well as with other bundlers. This is an example of the Webpack loader configuration. So it's really simple. It doesn't support TypeScript configuration options because it doesn't need them. These are the claims that you can find in their website. It's been tested with many big applications, and it works great and fast. This is the speed, 20 times faster than Babel, so that's even faster than the SWC. That said, now I'm going to cover what happened when I tried Cirera in our code base. I don't know how many lines Nick said, but the same lines.
Half a million, yeah.
Around the same. I don't think we created a million lines more in the span between your when you run that and when I run this. But we had a number of problems. Most of them were syntax related. There are some examples that they're including arrow functions and types, as well as exporting types as if they were runtime values, which obviously will crash when you run. We filed 9 issues, and 7 of them are already resolved, and the 2 that are left are not that important. They are about the source maps, and the other one I don't remember what it was, but not that important. So basically, our code runs now with subtrays, yeah, we filed all this, but most of them were fixed within a week, which is crazy in my opinion. There's one person running the show, essentially. And these are the performance. This is the performance stats. Here I was playing also with having the cache loader that he mentioned earlier, as well as thread loader, which basically separates the work on the different files into different parallel threads. And you can see there's a significant improvement on the first build. You have to keep in mind that the first build also takes care of building the cache, so that is included there as well. It's less significant when you run it again and there's the cache improvements.
Can you read what the bars mean, because you can't see it from back here?
Yeah, the first one says first run and build a cache. The second one says second run, cache. And the third one is change one file. I didn't say touch because I actually changed it just to see that it had to see the differences.
What about the colors as well?
So the blue one is subtrays plus cache loader plus thread loader. The red one is subtrays by itself, no caching, no nothing. And the yellow one is TS loader plus cache plus thread loader, which is what we're using normally or traditionally here. One interesting fact about this is that the TypeScript type validation, which will run separate from the transpilation, was positively affected by this because it didn't have to compete with for CPU, I guess, and memory resources since Cirera had already finished, right? So it had resources to finish earlier. And we've seen that in more powerful machines, mine is not the best, this is not so significant, but still you get good improvements like 10 seconds difference. So from 47 seconds in the TS loader plus cache plus thread loader to 37 seconds is a 10 seconds difference in the first build. It's still significant even in a really fast box.
So you're running both. You're running TSC and Cirera.
Yeah, so all these tools that I'm mentioning what they do is only the transpilation, and you are supposed to take care of type checking by yourself. You mentioned what's the name for PS4?
Yeah, something like that.
Yeah, there's a plugin for Webpack that you use that runs the TypeScript compiler, but limits it to just doing the type validation, which means we'll let it do that, and here we just focus on getting some text files that are in TypeScript into JavaScript. So interestingly, it surfaced some issues that we hadn't seen, including unused imports that were using the same name as some class that we had in the file, which was weird. We thought that that was a thing of the past, and some other type errors, but TypeScript has been getting better in the last few versions, and they've also caught some of this. And also, interestingly, we had old JavaScript code that did some introspection and said, hey, I want to see the actual source of this function that you're giving me, because I want to know the names of the arguments that you expect. I don't know why it was doing the introspection, but basically it broke because, well, now there's a different syntax. So we had to fix some unsupported, no longer maintained JavaScript project to make this work. In conclusion, Cirera is the only one that works in our code base. All the other ones have enough problems that won't work unless we file again a number of issues, and hopefully they're fixed. And 10 seconds in a fast machine is probably good enough for a developer to be happy about trying this. Right now, here we have it enabled under a flag. So we're trying and seeing if by running it enough times we find some significant problems or reasons why we shouldn't run this normally for developers. Again, in production we still use the TypeScript compiler for everything, and I felt like I had to put that because I had only put one image, so that's not legal, I think. But yeah, that's it.
Anyone have questions?
If you were starting a project from scratch, how would you set up the TypeScript build?
That's a good question. I guess a lot of this depends, obviously, on the size of the project. A lot of these tools you really don't need. If the project's going to be small and you don't expect it to be that large, you don't have to jump through all the hoops and use these extra third-party tools like we brought up. This only really comes into play when you have a project large enough where you're really starting to wait for long periods of time while compiling. So it's heavily dependent on the project. So honestly, if you're starting something brand new, I would just start simple. Just use the TypeScript compiler, just vanilla by itself, or with TS Loader with Webpack. And once you actually start hitting performance issues, then start looking at some of the other options we brought up.
Also, there are we've talked a lot about Webpack because that's what we use, but there are other bundlers that already have this idea in mind of we're not going to think about older JavaScript versions and older browsers, and they have a TypeScript plugin that you just put in, and everything will work. And for a small project, it will be really fast. Yep.
Is your UI all one package?
It is.
Okay.
Yes.
I was just wondering because I was wondering like how this would compare. Like I'm wondering what TSC with build info would compare to like breaking into packages and then building individual ones. Of course, you could do both, but I'm just curious how much that buys you.
Yeah, I'm not sure.
I was going to ask about the TSC like composite flag that they added recently.
For project references.
Yeah.
So if you guys know about project references, but you can actually have multiple TSC configs that are called by like a root TSC config, all with like separate settings. And when you have that turned on with the composite flag, it actually by default enables the incremental build so that it doesn't have to go out and actually rebuild all the projects on any change. It'll actually cache the results of each of the sub-projects with the project references. That's about as much as I know about that, but yeah. Any other questions yet in the back?
That graph you showed, you said on more performant computers it didn't have as much of a difference. Could you give any specs for the computer that the graph was generated on? Like number of processors, threads, memory spec,
It has
SSD?
16 gig of memory, I know that much.
It's actually 32, but it's an i3 with
I think
4
it's
cores.
Yeah, like a 5-year-old i3.
Yeah.
I want to say.
Yeah. So it's bad enough that every time that it tries to, TypeScript compiler tries to just run for one file that has changed, I'll fill it and things get slow, including like VS Code, etc. If that helps. With Sucrace, of course, like I suffer less.
How many times did you run those tests, like deleting those builds, or the like build info thing that you had, so you had a fresh run from the start to like get a what's the word, p-value or whatever?
Standard deviation, just how much variance in the actual results.
Yeah.
At least for the ones that I had posted, I ran them like 5 times, and they were all probably within like 1%. So I didn't even really feel the need to like post the variance, but it was all pretty close for me when I ran mine. But I don't know, Kilian, if you noticed any bigger variance jump in yours.
No, I ran mine like 3 times, I think, and I wasn't trying to make like stats that are significant for everyone, but they are indicative of a pattern. I think like what we saw with just looking in a way is that there are significant or important differences in the speed. So anyway, what I would give you would probably just be just apply to me. But I think it does show it's a lot faster in general, like they claim in the case of Sucrace.
Does Sucrace support a watch flag?
Yeah. So it doesn't need to because it's Webpack does that. Sucrace is just worried about if Webpack says you have this many files to look at. Webpack will Sucrace will load file by file, and if you have the cache loader, well, it means that will get reduced into 1 when it already has a result for it. But yeah, Sucrace doesn't care. Just you tell it how many files, and it will go 1 by 1. So it's up to the bundler to tell it how many. Yep.
So you shaved 10 seconds off the build time. At what point do you think you actually recouped the energy and investment into Sucrace?
The energy investment wasn't that big. I think what was interesting, and if you look at the code changes, the only significant ones, interestingly, were ones that we wanted to get done anyway. So, for example, we wanted to get rid of namespaces and artifacts from older JavaScript versions or TypeScript versions. We did have to file the issues and wait, but really it wasn't that much of an investment. Ideally, like the promise, and it wasn't fulfilled, at least in our case directly, but the promise is that you tell them run and they will just run. They are supposed to understand TypeScript. You shouldn't have to do anything. So our gotchas is, these projects are new. We found that they didn't deliver on that promise, but with about 9 issues, they got to completely make a good version of our, I think, pretty big project. So I think it's in a reasonably good condition. And then the gotcha of a really old JavaScript project that did introspection. That's not a problem with Sucrace, that's a problem of what version of JavaScript you're compiling to. If we had the choice of doing that with TypeScript compiler, it would have the same problem.
Yep.
I'm curious what your experience was with non-type things that the TypeScript compiler does, like async await. It blows your code up to wrap promises and all this crazy stuff, but Sucrace says that it keeps your lines aligned, if I was understanding that correctly. So did you run into anything like that, and how did it do it?
I didn't run into any problems like that. I also didn't go through all the files looking that they actually, that it actually was the case, but I never found any case when I was looking or going through the different issues where it didn't. So I'm not sure. What I can say is that at runtime, everything related to promises works. I'm also not sure right now what part of it is transforming. In theory, it does very little transformation, as little as it can. So there's very little chance for that sort of problem to occur.
Yeah, in modern ES, it shouldn't need to do that much to construct the state machine, because JS will already capture the locals in the .then enclosure. So if you just replace the await with a .then and indented the next block, that would have the desired effect.
Any other questions? Yeah.
Yeah, you mentioned about the last compiler, that one of its advantages is that it generates very modern JavaScript. When you compare this compiler with the other options, did you set up the target of the other compilers to a modern JavaScript, like ECMAScript 2018?
So I think we have in our TS config, which I think was also used by Sucrase and everything, our initial transpilation target is always ES6, correct me if I'm wrong on that, and then we'll use Babel to convert ES6 into, depending on what browser you want to target, down from that. So I think we were strictly targeting ES6 at the TypeScript transpilation level.
And for the other ones that I tried, I was trying to do the same as Cirera, to compare them equally. So the idea was I don't want transformations because it's for dev environment. I'm going to be running Chrome or Firefox latest. I'm not going to do testing per se. I'm developing, so that was the target. But I think it just by having to support the other things. In the case of the TypeScript preset for Babel, just by having to then handle it to Babel and do whatever transformations, you incur some pain for that. And you can imagine the code itself becomes a little bit more complex in its architecture. And same for the SWC. It does a lot, it does so much, and just that complexity, even if you are opting out of it, also, I'm supposing, without having looked in detail at the source code, I'm supposing that that's the cause for it, and the success of Cirera is basically it tries to do very little, so it does it well.
Any more questions?